Hi everyone, so we're up to tutorial 10, question 1, part II. We're asked to find the process described by y of s is e to the s. So we can see that the process only depends on s, doesn't depend on t. So similar to the previous question, we're going to use Ito's formula. And we're going to take a look at the function f of s equals e to the s. Okay, this is going to help us because the process y of t is e to the s of t, and that's basically exactly what we're looking for. So this s here is big S, just viewing this as a small one, just to make them look a little bit different. Okay, so we need to use the second equation that we derived, which is this one here, because it only depends on a single variable over here, which is s. So if f of s is e to the s, we're going to need to know some partial derivatives. Okay, so let's do that next. We have the f ds is the same as d2f ds squared, which is just e to the s. So if we substitute this in, we have dy, which is dE of st, which is big S, is mu st e to the st 1/2 of the volatility squared. I'll write that a bit clearer. St e, I've missed the squared off again. E to the st dt plus sigma st e of st all multiplied by dB. And I'm going to collect all the I'm going to factorize the e to the st's, which are just y. So actually we have the following: sigma st 1/2, mu st plus 1/2 of sigma squared s squared t est, which is y, plus sigma st y times dB. Okay, this is looking good, close to the end. For many questions, that would be the final answer. Do we need to do anything else with this? Okay, says express the coefficients using y's, not s's. I'm not sure if I did that on the last one. Let's do it for this one. Okay, so we want to remove the s's, and we know that, okay, I'll make a side note. Just collect my idea. We know y of t is e to the st. Oh, we can just rearrange this. So we have log of y of t equals s of t, so we can just drop that in. And that will complete the answer. I think that's standard notation for the log. If it's not, it is now. we're finished. This is the final answer. The change in this process using Ito's formula is expressed in that purple box. Great. Okay, so this one I think seemed much nicer than the previous example. The only reason was that we'd already derived all the equations, so we just did the partial differentiation here, which was very simple. We made the substitutions here. Again, it's just long, it's not difficult, just long. And then finally, probably the only tricky parts, extracting the y's and substituting in for s of t using y, which involved a small side note there. Okay, I hope you find that useful. Let's take a look at the next one in a different video.